implement that in one of the major platforms for hyperscalers. And I'm delighted to welcome Mark here from AWS, who can introduce himself, who's going to walk us through from the top 10 all the way to agentic top 10 and how you possibly kind of relate that to an AWS solution. Nice. Which means we need to all sit down and pay attention. Thank you.
Yeah, I'll just wait for John to do the roundup. Thanks, John. Thanks, everybody. It's amazing to think that probably, what, 2.5 years ago, not many people in this room had actually heard of generative AI. I know I hadn't. If I think back to where I was in 2023, if we look back, was it March 2023? Microsoft and OpenAI put out their announcement. At that point, kind of the world kind of woke up. We saw all the news articles. Skynet is coming to take over the world. All our jobs are gone. Chatbots are the future. About 5 or 6 months after that, OWASP released the large language model for top 10, 2023 version, pretty quickly. Jump forward to 2024, and in November, December time, I think it was, they were launched and OWASP released the updated large language models for top 10, the 2025 version. At about the same time, Anthropic had just open sourced MCP, Model Context Protocol, that they put out there. So we kind of jumped immediately from generative AI and large language models to now we're starting to use tools. In Q1, I think it was February, OWASP dropped out their Agentic AI threats and mitigations documents. They turned it around pretty quickly. And then look where we are now. We've just had the launch of the OWASP top 10 for Agentic AI applications. Things are moving rapidly, right? I started this 2.5 years ago, roughly middle of 2023 when I picked up generative AI security. And I always joke in that I'm actually only 27 years old, and this is what 2.5 years of agentic AI security has done to me. I heard somebody say that actually a year in AI security and agentic AI and generative AI security is the equivalent to 10 years in real life. So it kind of tracks pretty well 2.5 years to where I am now. But the reality is this is moving rapidly. A lot of the information that we get, and actually a lot of what we've spoken about today has all been, hey, here's the theory of how we do things. Right. I'm Mark Keating. I'm a Principal Security Specialist at AWS. I've been at AWS for almost 6 years. And for the last 2.5 years, I've been focused on generative AI security. And what I've been focusing on is actually going into customers and talking to them about what it is, how it looks, and how they can and what they can do to mitigate those risks and the security issues surrounding generative AI and building applications using large language models and now agents. So if we look at the evolution of AI, AI started back in the 1950s, really, but that was long before I was born. If we start looking at from a machine learning perspective, and we kind of go through in terms of where we are, we had machine learning for a number of years. For a long time, it was fairly predictable. You put a bunch of data in, it would spit something out. It would give you a prediction. It'd give you a yes or no. This is good or bad. Something's going to go up or down, right? Simplistic view, but that's machine learning. It was very constrained around what it was going to do. 2.5 years ago, large language models and generative AI came in, and all of a sudden, we were starting to expand that. The security controls that we needed, the privacy, the risks associated with all of these things started to grow. 9 months ago, agents started taking over. So you can see how we're accelerating through this. To be honest, the next time you see me, maybe next year, I'll have a big white beard and I'll be ready for retirement because I would have aged another 10 years. But the point is, who knows what's coming next, right? It could be in 6 months' time that all of a sudden somebody goes, do you know what? This agentic stuff is great. We've gone from single agents to multi-agents to now everybody's going to have their own personal agents that's going to grow with them for the rest of their life. I don't know if that's true or not. We don't know where it's going, but the point is it's going pretty quickly, right? So what we really have to think about is, and when we're talking to customers, there are three things that we tend to talk about customers. And if you notice I'm talking a bit quick, it's only because obviously John's put me under pressure to make sure that everybody can get out for those drinks and things later. But realistically, trying to summarize what I've been doing in 2.5 years with customers into 45 minutes is kind of tough. But when you to think about things strategically, what we need to start looking at is AI is going to become embedded everywhere. We're starting to see it already. Whether you know it or not, supply chains that you are using today are probably using these tools, and you may be unaware of them. It's happening. And just by show of hands, how many people currently have generative AI or agentic AI applications in production? Okay. So let's say a third of people. How many people are organizations are experimenting with it? A bunch of other people. And my assumption is all the people that didn't put their hands up probably don't know it's happening somewhere in their organization. That's the reality of it, right? We heard shadow AI being spoken about earlier. This is happening, it's coming everywhere. Security needs to be embedded everywhere AI is integrated. We heard a lot earlier about threat models. We heard a lot about knowing and understanding what the infrastructure is, where those integrations are, and how are you going to protect them? How are you going to secure them? What are you going to do to make sure that they don't have unnecessary access? Same as when I get access to systems, I only get what I need. At least HR know who I am and what my job type is. As soon as you start looking at these integrations, we really need to dive deeper into the infrastructure to see where these agents are where they're being integrated, who's using what. And then finally, we're hoping that in an ideal world, everybody's got their foundation security in place. Everybody's doing security right. Everybody's got their foundations there. The reality is, we know that most organizations have challenges in getting everything there. What we're hoping, and in an ideal world, is where the boards and the senior leaders are trying to drive security, trying to drive AI, and they're trying to drive agentic and generative AI applications that can actually help drive security across the environment. Right? By raising it as a risk and by getting in there early and by getting leadership to buy into it, hopefully you'll be able to actually take those business cases and your leadership are going to say, actually, yes, we can do this, but we need to put the right controls in place, which is hopefully going to be able to help fix some of those foundational challenges. So in some cases, we can actually see that these scaling AI and securing AI can actually help drive your security posture as a whole. Can't guarantee it's going to work for you, but you can try it. So what really changes with AI? And there are 4 key things, and I'm just going to bring all 4 of them up really quickly. We've heard some of these things spoken about before, and I'm just conscious that the white text hasn't really come out particularly well on the screens. Non-determinism, we've heard that raised before. You can ask a large language model the same question 5 times, and chances are you'll get 5 different responses. Right? The sentiment may be the same, but the actual response is going to be different every single time. We've moved to input becomes code, whereas before what we would do is we would actually send an instruction and it would go and interact with code or with data in the background. Now what we're doing is we're sending an instruction as well as information that all get packaged up. We heard Dan talking about emails containing code in there that could actually use for prompt injection attacks. There's a number of things like that. But essentially what we're doing is we're bundling up the data and the control together and sending it through to the large language model. The large language model really can't differentiate between what it should be using and what it shouldn't be using. It's just going to take that as an entire whole and it's going to execute it as code. We consider things like autonomous decision making. We've heard about this before, and actually, on the back half of my deck, I'm going to talk about this a little bit more around the autonomy that we're giving these tools and the ability to go away and make decisions, make changes to your environment. And then the last one there is around actually dynamic learning and the fact that agents, depending on how they're built, can actually learn. They can improve and they can change over time. This is fundamentally different to a lot of stuff that as technologists we've had to deal with in the past, especially from a security perspective. So when we're thinking about this, and when I go in and start talking to customers, we try and take the emphasis, maybe emphasis is the wrong word, we try and step back and we say, let's look at the things that we can control from a security perspective. Let's start looking at what's happening outside the model. So let's start looking at those deterministic controls, the things that you're doing today already, the least privilege, the data protection. knowing what's going on, the logging, the monitoring, and so on. Right? Let's look at those things and how we can make use of those to our benefit. Security, apply security before anything goes into the models. Right? So how many people today are going to deploy an application, a web app, without putting some kind of web application firewall on it? Right? You're not going to. The threats are enormous. Essentially, you're doing the same thing. You're stopping the data, the bad stuff from getting to the model. You're stopping the bad stuff from getting to that web server, right? Think about that something. And use defense in depth. We hear this all the time. You know, multi-layered approach. There is not going to be a single control that's going to be perfect for every single thing. You have to use a defense in depth approach. So there are three key things. I mean, there's a whole bunch of things, but there are three key things that I really look at. What are the threats? Everybody wants to know what they are. What's actually relevant to me? Because there might be a whole load of threats out there that are not relevant to me. And then what can I do about them? And we always hear a lot of theory about the things that you can do, but not how to do them necessarily. You know, so things like reduce the surface attack area. And you go, okay, in real English, what does it really mean to me as a practitioner or a security architect, somebody who's trying to deploy something a little bit? So we've tried to take a step back and we started looking at actually what do some of these things mean and how do we approach this? So I'm hoping everybody has seen this. This is not today's, this is the 2025 version of the OWASP Top 10 for large language models. I'm not going to talk you through this. It'll take far too long. Everybody's aware of this. The one thing that I will point out is every time I talk to anybody about this, there are three things that always come up. Prompt injection attack, because everybody's super scared of prompt injection attacks. Rightly so, you can do some bad things. Sensitive information disclosure. Actually, I don't want sensitive information to be disclosed because I could get into a lot of trouble. And the final one is excessive agency. Right? Those are the three top things when I'm talking to customers that tend to come up. Now, different people have got different use cases, different people have different priorities of things, but those are the ones that I see time and time again. I don't see very much about misinformation, which arguably is quite a dangerous one. You know, do I trust what's coming out of those models implicitly enough to be able to go away and use it without validating it? So up on screen, I'm just going to go through this pretty quickly. Very, very basic, high level. This is meant to be simplistic view of a large language model based application. I send a prompt in, goes to the application, it sends it off to the large language model or an agent. That goes off and checks some information. If there's any supplemental data sources that are there, it formats a response and it sends it back to me. Nice and easy. Then we add in where the models come from. We've got our data producers on the bottom. They produce a whole lot of data. They push it in. We train the models. We've got, when it comes up, we've got machine learning engineers, data scientists. They take their own data, they extract from somewhere, and they do some fine tuning of models, and they push that into there as well. This is a super simplistic view, but the reason I put this here is to understand how things like the OWASP Top 10 for large language models can be overlaid on this. So now when you start looking at this, what we've done is we've overlaid all of these, right? So the idea behind this is that it helps to give you an idea of which threats are relevant to which parts of the application. This is a high level. There may be nuanced versions depending on what your application is, but this is a very basic starting point. The challenge is not everybody has a full end-to-end application that they built. So the threats that are applicable to me as somebody who's building an application from scratch is very different to the threats from somebody else who's buying an off-the-shelf service with GenAI capabilities built in. The good news is we created something about 2 and a bit years ago called the GenAI Security Scoping Matrix. And what we did, excuse me, quickly. And what we did is, based on a number of conversations that we were having with our customers, we found that there was a lot of confusion and business cases were being mixed up, right? Somebody was looking at risks that were associated with free versions versus somebody who's trying to build something themselves, and it was really difficult. So we went and we spent some time. We essentially categorized generative AI and large language models down to 5 distinct categories. The first 2 are buy, right? So scope 1, this is around your publicly accessible, typically free type services. You can pay for them. But think of your ChatGPTs of the world. Think of any of those free type services. You have no control over anything once the data goes in. Scope 2 is all about enterprise applications. That could be coding assistance. It could be Copilot, Amazon Kiro. It could be something that's embedded into Salesforce or any other service like that. But ultimately, this is where you've got some T's and C's. You've got some contracts between you and the supplier and the vendor. So there's a little bit more control, but still ultimately, this is a buy service. You've not had to do anything. You're buying these. Then we shift over to what happens if I want to start building something. We figured there was 3 distinct categories for build. I'm building an application using a pre-trained foundation model. I'm not making any changes to the model. I may have some external data sources that I'm going to augment it with, but ultimately, this is around me using an application with a pre-built model that I don't touch. Slightly different if I want something that's very specific to my needs and my business case. So I'll go and fine-tune a model with data that I've curated. And then on the very far right of your screen, you'll see scope 5, which is around, I built everything myself. I gathered the data, I curated, I cleansed it, I built the model myself for whatever purpose. And with each of these, there is a slightly different approach when it comes to privacy, legal, compliance, risk, security controls, resilience, depending on which scope you're in. So we see there's a QR code there. This will take you to the launch blog that we did about 2 years ago. And we've got a series of 5 blogs in that where we actually cover privacy and compliance. We cover security controls, resilience, as well as threat modeling. What we then did is customers were like, this is great, but I still need to know what I need to do in my environment. What tools should I actually be using in order to implement some of these things to protect us, to mitigate against them? So what we did is, first off, is we overlaid the OWASP top 10. Right? So we looked at OWASP top 10 and we said, generally speaking, this is how the top 10 for large language models will overlay onto that scoping matrix. Now, depending on the application you've got, there may be some minor nuances here, but if we look at something that you take off the shelf, I have no control over prompt injection attacks. I have no control over vector and embeddings weakness feeds. So it's not applicable from that perspective. But as soon as I move into I'm building it myself, we start putting out the things that are applicable from a large language model. And the only one that's really different here is in scope 3, you'll see what's it, LLM 04, which is around data and model poisoning. At its bare minimum, because I'm not changing the model, and if I'm not introducing any external data sources, that just doesn't even feature, because I can't control it. As I said, it's all about nuance. If I've got external data sources that I'm hooking into this, then maybe LLM 04 is relevant to me in this example. Right? But this just helps us, and it gives us a bit of scope that we can work with. In those blogs where we go through actually a lot more detail in terms of things to think about. So even though these may all align across all the different scopes and the information around security, privacy, compliance, etc., we've actually broken it out because we see incremental changes as we go through the different use cases. And then what we did is we then said, actually, now if you really want to build this and mitigate it, these are some of the tools that you can actually use. Right, so rather than just saying, go away and go do this stuff, what we've done is we've actually put it in place. So we've put this out there to say, go do this stuff. And these are the tools that you can actually use to help you. Now, just because you go and implement these tools is not going to fix all of your problems, because obviously we just spoke about this earlier, and that defense in depth, right? It's a layered approach. And actually, this is not going to fix any vulnerabilities that may exist within your application network and vulnerabilities that are out there. So it's about running different iterations, different tests, different checks to see what's vulnerable where, and applying the correct security controls at the different layers. But specifically when it comes down to mitigating the OWASP top 10 for the large language models, this is a set of tools that we came up with. How many, out of interest, how many people have seen this slide? And very few. So I was introduced to this, I think this was released in Q1, thereabouts, maybe late Q1, beginning of Q2, somewhere like that. The large language model application SecOps framework from OWASP. And they put it out there. I had a look at it. And it wasn't up until probably about 3 weeks ago that I actually had a customer say, actually, we're looking for a framework. How do we do this? What can we do? We want to go right the way through from build and deploy to maintain, right the way through to operate. How do we put in a governance process? Or what does the life cycle look like and how can we do this? So I remember seeing this, I pulled it up, and then I did exactly the same thing, and I've shared this with them. Right. So what we've done is we've taken this and we've started building this up. Now, this is just a initial draft of how we've overlaid some of our AWS services. You could take this and create your own version and look at the cloud vendors that you've got. You could make this specific to each cloud vendor or on-premises environment that you've got and put in your third-party tools, put in your open source tools that you've got there, whatever they are. But ultimately, you can take this and use this as a template. It's not mine. Go onto the OWASP website, pull it down, make your own version of this. But I've shared this. I work in our global healthcare and life sciences group with our global healthcare and life sciences customers and our global automotive manufacturing customers. And I was talking to one of our large life sciences and drug development companies, and this is exactly what they were asking for. This was 3 weeks ago. We were talking to them about this, and they said, "Hey, we got something like this that we could use." I pulled it up. That's fantastic, and we've done this. We've implemented this. Well, I say implemented. We wrote this all up. We shared it with them, and what they're doing is they're going to then overlay their own tools and services that they've got, those commercial tools and open source tools that they're using. Because now what they've got is they've got the framework that's there. Now they just need to work on the process that backs it up. How do you step through everything that's there? And just for fun, we shared this as well. So we've got the large language model top 10 mapped to MITRE Atlas as well, because depending on who you're talking to, some people are more interested in high level. I want to know the basics, which is where OWASP is really, really good at explaining, especially to leadership. It makes it super quick, super easy to understand. But as soon as you drop down to MITRE and you're starting to talk about those techniques, tactics, and protocol procedures, all of a sudden, leadership eyes glaze over, and they're like, go talk to the tech guys who are going to fix it. And you can go and you can take this and say, or the forensics team, the pen testers, whoever, and you can go, here's a whole lot of stuff from MITRE Atlas that is directly related to this. And that crosswalk of mapping between OWASP and MITRE has been super helpful a few times. So what about agents? Yeah, I think I'm doing all right. I'm making up a bit of time. So you've seen this all today. I'm not going to talk through this one. You've seen this a good few times. What I am going to do, though, is remember the same process. What are the threats that are applicable to me? Here they are. Right. If I talk about what's relevant to me, here's what I prepared earlier. So if we look at this diagram, similar to the other one, but actually this is a focus on agents and how agents work. At the top, you've got the application, or machine interacts with the application, sends an input down to the agent. The agent is broken out into a number of components. Specifically, when you look at it, you've got around planning, the actual tool calling, chain of thought reasoning. There's an integration with a large language model somewhere along there to do something, generate something, get some information back, looking at all of that. Then there's the actions, going off and taking those actions based on the tools that you've given access to, feeding it back up to the application, or in a multi-agent environment, going off to another agent. Again, super simple, but it drives the point home. So now when we overlay the agentic top 10, we get something that looks like that. And that's before you've even gone into the other agent and then put all of these on the other agent. Right? So what this starts doing is it starts giving you an idea of what do we need to do where, and what tools and what services can we implement on there. Again, looking at how we're doing this previously, something that we launched 2 weeks ago, we created the agentic scoping matrix. So now what we looked at again is we tried to break down agents into their fundamental components and see how we could categorize them and how we could group them together. So we started off on the left with scope 1, which was no agency. We then moved right the way through to fully autonomous on the right-hand side. And you'll see this coming up time and time again. And it's all about the autonomy and the agency that's been given to that agent. What can and can't it do? So if we just, by way of example, if we look at scope, the first scope that we've got there, scope 1. Scopes 1, 2, and 3, by the way, are all human initiated. Right? So that means as a human, or something needs to initiate the agent to go and do something. So let's use this as an example. Scope 1. I go to a chat agent, or go to the agent, and I say, hey, I need to organize a meeting. These are the 6 people I need to do. And the agent's going to go away, check our calendars, and come back to me and say, I found this common time. What do you want me to do? Or in this case, scope 1 is not even what you want me to do. It just comes back with the available time. I then take it and I put the calendar entry in and I send it up. Nice and simple. All the agent is doing is it's going retrieving some information and giving it back to me. Scope 2 takes it a bit further. That same thing, I ask exactly the same question. It says, I found this availability. Do you want me to book that meeting for you? And I go, yes, book the meeting. And it goes where it does the meeting. Right. Scope 3, now what we're doing is we're coming out of that meeting and I say, I need to book this meeting. Can you go find the time? It goes away. It automatically finds a common time and it books meetings for everybody. I don't have to say yes. It just goes away and does it because I've given it trust and autonomy to go and make the change to the mailbox or that calendar. And then scope 4, fully autonomous, no human involvement. I come out of a meeting, my meeting notes are dropped in somewhere, and the agent automatically picks up that I've been to a meeting. There's some meeting notes, and in those meeting notes, it says I need to organize a meeting. It goes away, identifies the key stakeholders. It does what it needs to do, and reorganizes that meeting and puts that in everybody's calendar for me. So at no point did I ever go and say, go and book that meeting. It just went and did it. That's a super simple example. I'll give you a real example that I experienced last week. So I've been experimenting with our Kiro development environment. And like most people, you tend to get a bit lazy when you have to click next, next, next all the time, because scope 1, scope 2, actually scope 2 says, I want you to tell me every time you do something because I want to say yes. And after about 50 times, you get a bit lazy and you go, I'm just going to trust that command. You get used to doing that. You want to trust that command. Fortunately, this is an enclosed environment, experimenting with it. So what does it do? I'm busy trying to do a test, and it automatically decides it needs to use an MCP server that I previously disabled because I was trying to test without the MCP server. It goes, automatically says, actually, you've got this tool here. You've given me autonomy to do what I want to get this to work. I'm going to go and re-enable this MCP server for you, and then I'm going to get you the results. And I come back and I'm like, this is pretty impressive. Without the MCP, it did that. Until I read the logs and was like, yes, I have to do this. So bringing it back to real world examples, that's one where it can go wrong. The other thing is I told it to go ahead and do something. It said, in order to do this, I'm going to have to delete this. Are you good with me? It just didn't. I tested something 10 minutes later, it was broken. So I just typed into the chat. This was working 10 minutes ago. What's happened? Oh, let me check. Oh, by the way, this function, this code is missing. I'm like, well, where's the code gone? It's like, well, I deleted it because you asked me to clean up. It's like, well, fix it. It's not my problem. And it came back going, I'm sorry, I don't have a backup. Right? So these are real world examples. They are minor, they're experimental, they're enclosed systems. The point is, these are how things can evolve and change. And your processes need to change with them, and education is key. Right? Humans, by default, are lazy. I hate to say we all are, right? We will all take the easy routes wherever we can. So by implementing guardrails on the back end that allow you to do certain things or prevent you from doing other things, getting used to and being educated on the things that you should or shouldn't be doing and the way things are going to react and the potential implications of doing that's not key. Education is really key here. But I do see this evolving as we go forward, and I think people start getting used to it and they'll learn. They'll get into it, there'll be processes, we'll put the guardrails in place. Now, given that I spoke to John literally 2 days ago, I've tried to map the OWASP top 10 agentic version onto here. And what I came out with was this. Slightly different to the previous one. What I've done is I've categorized this in risk levels, low, medium, high, and critical, based on what you lost. So we start off with scope 1, mostly lows. One of them is not applicable just because I can't remember what ASIO 7 was. It was, insecure interagent communications. That's because scope 1 is a very simplistic single agent environment. It's never going to have multi-agent, so it's not going to be applicable at all. We then go on to scope 2. Most things are medium. Scope 3, most things are high, with 1 medium high, and then full autonomy. Pretty much everything's critical. You need to make sure you're on top of this stuff. Right. So this is where we are. Bear in mind, this is only a couple of days old now. This is at a base. Right. Again, depending on the use case, depending on your application, these things are nuanced. You may find that actually, if you're doing something at scope 3, that your application, the way it's configured and built, actually some of these may or may not be a higher or lower risk, depending on what it is, depending on what the actions are that it's taking, depending on the type of data it's interacting with, the systems it's interacting with. So the key thing here is to sit down and understand what's happening and where those interactions were. Remember what I said earlier about actually understand where those integration points are? This is going to help drive what your risk levels are and where you need to apply things. So I then got a little bit excited. So I started saying, I'm going to start mapping the LLM 10 to top 10 to the agentic top 10. So I started and I kept on going. And I kept on going. Oh, I'm a bit too far. And I gave up after LLM 04 because I realized I didn't have enough colors and the number of lines were just going to completely obliterate the token. So I ended up going the old school route and putting it into a table, which made it a little bit easier to read, bit of clarity. But essentially what we've got is on the left-hand side, we've got the agentic top 10. In the middle, I've mapped it to any of the large language model top 10 that I believe it maps to. And again, this was on the back of a serviette, writing this thing down super quick in the last couple of days, just to try and get this out there. Again, nuance, depending on the application you've got, depending on what you do, understanding some of these things a bit more may change these values, may change the table slightly. But the column on the right is probably not going to change too much because again, these are the services that are going to help you mitigate against those agentic top 10. So we've got things like Bedrock guardrails. We've got things like your identity services, identity and access management, Amazon verified permissions. We've got data protection in the form of key management service. We've got Mason to go and be able to tell you where that data is. These are all services that you're going to be able to use. We've got things like WAF, Web Application Firewall, Shield from a DDoS protection, right, for unbound consumption and rogue agents and overloading the systems and doing all of these things. Ultimately, when it comes down to it, the thing that I find amazing is from an AWS perspective, we've had years and years and years of AI services over a decade, right? From our original AI services to where we are now. And the thing that I find amazing is that our foundational security tools we've not introduced any new security tools as such. Encryption's been around for forever, basically. Least privilege, identity and access management, making sure that the right thing has the right access at the right time. It's been around for forever. When it comes to authorization and identity services, we've been doing that for a long time. Not just us, but everybody. And it's not that we haven't developed anything, it's the fact that those foundational security services are what we need to protect a lot of these services and these things. So when you're looking at some of these things, you'll see a lot of these tools on here, you go, I'm already using these in our environment. And that's great, because the idea here is not for you to have to go away and think, I've got to go and learn a whole load of new tools or a whole load of new services and approaches to things. What I really want you to take away from here is that actually you can use the same tools and services to secure your environment, but you need to know where and why. And that is a lot of what the conversation is that we have with our customers. It's around bringing them around from the initial panic of, we've got to do this AI stuff. Help. I don't know what to do. To actually grounding it to, those security foundations that you've got. The teams don't necessarily need to go and learn a whole lot of new stuff, but you need to spend the time and understanding where those integration points are and the impact of that application, the risk of that application, and making sure that you tie it down. That is arguably where we spend most of our time, is helping customers, grounding them and helping them. With that, I think I'm good for time. Thank you very much. Hopefully that was useful. I'm going to be here afterwards if we want to ask any questions.